All right, we did this one together and we condensed it by first. We couldn't use this second log rule until there was no number in front of the word log. So we moved the 6 that was here up here, and then we condensed it by dividing the arguments. Very good. Can you do that tomorrow? That's not too bad. You got that? All right, let's do an expand. You can just tape that, keep the tape running. All right. Oh yeah, we do have to do that 10-minute thing.
Oh yeah.
So, all right. So we'll have to mess with that in a minute. Expand. One more expand. We practiced these last week, but just to make sure. So this time we're doing the opposite. I'm taking one log and writing it as many logs as I can. So that's a base 3. Can you tell that? It's not part of the square root. That make it a little clearer? All right, you need to expand that. I'll start it on the board. Just keep working and ignoring what I'm doing. See if we get to the same spot. Did you recall that the square root of x can be written as x to the 1/2?
I did not, but I had a friendly reminder from Amali.
Okay. Alright, did you get what I got? Alright, so that's how you expand. It's sort of the opposite of condensing. Alright, let's go ahead then and leave that behind and start solving equations. We're going to solve an exponential equation, and I patterned them after the test questions, so we're not really wasting any time today. We're going for the gold. 4e to the negative 0.02x plus 72 equals 83. All right, Molly, what's the first step on these kind? We're trying to get, when the word is solved, the command is solved, we want at the end of the story, we want x by itself. So what's the first step? Then we talk about blooming onions. When we did that, it's like a big onion, and we're going to go out from the outer layers in toward the x. So Molly, what's the first thing we can do?
Subtract 72.
Right, so you're not going to deal like with the 4 first, because you have to go to the outer layers and move in. So subtracting 72, what is that, Molly?
I should be able to do this in my head, but 11.
All right, sounds like you did. All right, Hannah, take another layer off our onion.
Would you do the ln yet?
No, because there's a.
Oh, you divide by 4.
Right, you have to again go from the outer in, and that 4 comes up next. So what is 11 divided by 4?
2.75.
Point what?
75.
2.75. All right. So Allie, the unknown is up in the exponent, and what do we do to get it down?
You take the ln of both sides.
Right. It doesn't matter if you took an log, but ln will simplify this one. And so we take the ln of both sides whenever the exponent needs to come down because of the third log rule. So we can then move the negative 0.02x down and find out the ln of 2.75. This is a magic spot right here. Molly, what is ln of e? Because that's base e.
Isn't that just 1?
Yeah, it's what exponent do I give this e to get that e. So do you notice this can just go away? It's a 1. So now all I need to know is what is, you can go from there, find out what is ln of 2.75 and divide it by negative 0.02. Tell me what you finally get.
Divided by what?
Negative 0.02.
0.02 is negative 50?
I got 1.
That's not right. I got was right wrong.
I got negative 50 as well. I had ln of 2.75 was 1.01,
Mm-hmm.
and then I divided.
Oh, it was. I did it the other way around.
And when I divide it by negative 0.02, I got negative 50 around 0.5, something like that.
0.6.
Yeah,
Now, do I have to check this? Do I have to do a check there
No.
on this one?
No.
See, there's no word log up here, so we're done. So these are called exponential equations, and that's how you do those. So you okay with that tomorrow?
Yeah.
I think they're going to do really good on this test, because these are about the hardest as it gets.
Oh, really?
Oh, really?
Well, I think so.
I just have a tendency to blank out when I'm under pressure.
Yeah.
Yeah.
All right,
Should be fun.
next one, we'll do another
Nonsense
exponential,
language.
and then we'll switch to log ones,
Anything
so we can do our check bears.
Oh, we get the bear.
I don't know if I have them. I'll check. I have to check and see if I have the check bears. All right, this one, the exponent is really hidden. It's in an exponent, but it's in the denominator, so.
We multiply both sides by 2 plus e. to
Right,
get it out.
very good. So 2 plus e to the minus x. You comfortable with that? Hannah, Molly?
Mm-hmm.
All right. So that's gone. So we have 300 equals 1, 2, 3. You can tell I made up this problem. All right. So next, Hannah, your turn. What do I do now?
I'm thinking you distribute the 1, 2, 3.
You can, but
Can't you
there's a
just-
quicker way. Since
Can
we're
you
trying to get rid of the 1, 2, 3.
Oh, do you divide the 1, 2, 3?
Yeah, you can do what you
don't
said,
want
and
anything
you'll
from
get
that
to the
E.
same answer. It just take you 2 more steps than it'll take everyone else. So let's go the quick way. What is 300 divided by, so it's 2.44
Yeah.
2.4 equals 2 plus e to the minus x. Molly, take over.
It's gonna be 0.4 equals e to the minus x.
Subtracting 2. And back to you, Hannah.
I always get the one with the exponent.
Yeah.
Do you take the ln of both
Yes,
sides?
that's, you need to take some log. LOG would work as well, but this again will simplify. ln of 0.4, I got a negative 0.82 it looks like. And this negative x runs down in front. We know ln of e is just 1 again. So all I have to do is switch the signs, right? Yeah,
You
Hannah?
don't even need the calculator.
Yeah, what happened with that?
Is it 0.82?
Yeah,
I didn't get 0.82.
what happened?
I got negative 0.92.
Hey, what'd you get when you took, did you get 2.4?
Mm-hmm.
What'd you get when you took the ln of 0.4?
Negative
Yeah, I got the same thing as she
0.92.
did.
You did? Maybe I'm wrong.
What was it? The ln of 0.4?
Negative 0.916.
What's the ln of 0.44? Maybe that's just the difference.
Oh, that's 0.8. Negative 0.8.
Okay, alright. These decimals, when you're dealing with logarithms, make a big difference, so I'll take your answer as well. Alright? Alright, so that's all we're going to do with exponentials. I think you're ready for those. And now we'll switch to logs, log equations. That's where we do need to check the arguments. Alright, log to the base 4 of 2x plus 7 equals 2. Alright, when there's log on one side and not the other, jingle those keys in your mind.
Is that equals to?
Yes.
Oh.
Allie, what do we do when there's log on one side but not the other?
You change this to an exponent.
Alright, so what does it look like?
It'd be log, no, it'd be 4 to the second equals 2x plus
Right.
7.
Exactly. So then we have something very simple to calculate. 16 minus 7 becomes a 9. 2 divided by 2, 9 halves. Alright, what do we have to check about that, Hannah?
You plug it back into the argument.
Alright, do you really have to go actually plug it all the way in?
No,
You can see.
as long as it's positive.
Right, and you can see putting a positive number in there is going to create a positive number. So you're done, the check. So you can do a mental check And I know that if you circle that as your answer or leave that for me as your answer, I'm assuming that you have checked it. All right, next one. Let's try one where you have to use, there's logs on both sides. And we already did a couple of these on the green sheet, so we don't have to do much.
Ms.
Log to
Powell?
the base 4.
We're out of time.
Pardon?
We're out of time.
At the 10 minutes,
Yeah.
you mean? Okay, close it.